Did I already start the
Yes, started.
sharing? Just a second. I'll share my.
I'm sorry, my headphones don't work.
Can I share my screen? It says it's disabled.
Oh, I might need to give you rights. Okay, I have to look at this.
Think if you there's an arrow next to share screen, and then you should be able to allow multiple people. Been a while since we've used Zoom, I guess.
Okay, I clicked share screen, so
Yeah, I can do that.
okay.
Um, all right. Is it in full screen?
Yes.
Okay, perfect.
Yeah, looks good.
All right. Hi, my name is Tay, and this is a presentation about my research internship. I've done this project with Dr. Travis Wilshire and, of course, under the supervision of Kiana van Eindhoven. This project is about creating the data pipeline for incoming data from the Empatica device. Yeah, first for the problem statement, the focus of our research. When I first asked Kiana about what I could maybe help for her research, she was researching about teams in high stress environments and how they struggle with effective coordination and adapting to rapid change. And in order to combat this, you need a method. In this case, what we proposed was having a real-time data from this device called Empatica, where it measures the different types of signals from your body, namely GSR, the galvanized scalp skin conductance, or the heart rate. But in this project, we specifically focus on the GSR. And all the coding was done under the PP8 format. So basically, to dive in, this was the code that we had originally from the one of the laboratories. I have the reference in the appendix section. This code allows you to get the raw signal from the Empatica through Python. But okay, so uh, it combines with the server from Empatica, and it gets the data from that server to Python server, and then releases its data. And what it gives us is these kind of data output. So as you can see, there's all sorts of different signals that it gives us. But one thing is that you don't see GSR here. Uh, the reason behind that uh, is the SCR duration. So it takes more time for the GSR to be recognized because GSR only happens after the emotional arousal. So in this research, I've set that time as 20 to 30 seconds. Um, and after 20 to 30 seconds, these are the example of GSR data that we receive. So I had to, in some way, code in Python how to process this into readable data and also form this into a way that it can be later feature extracted. And this was my final code. I'm going to explain by bit. So for the method part, so basically we used a library called PyEmpatica. It was basically a bridge between the Empatica streaming server and the Python. Um, the pre-processing was done using splitting, as you can see from it had different, so it had to be splitted in order to made into readable data, parsing, and also the rolling mean calculation. This was seen in the EDA pre-processing of Kiana's work. So I modified it to make it be able to use it on the singular data, because essentially what I'm using is only one Empatica device. So I had to find a way to accumulate that data and then use the rolling mean. And also for storaging method, I use a method called caching, which is storing data in the temporary location. So for the caching, I defined two functions: process row function and store and clear function. So what it basically does, I'll show you the next slide and then explain the whole how it works. So it receives and processes data in a loop. So it decodes received data and then split it into lines, part of the pre-processing. And it appends the GSR data into a simple list. And then when it exceeds the window size, because the frequency of the GSR measured by Empatica device is 4 Hertz. So that's 4 data points per second. I times it by 30, so that's 120. So window size is 120. So once this list exceeds the window size, which is 120, it starts calculating the rolling mean, and then it stores the GSR data and rolling mean in a combined dictionary. And then to access that dictionary, you concatenate that cache data into a single data frame using the store and clear function. So basically what it does is it converts the cache list into a data frame and it appends it to the original data frame. So the data frame keeps on building up and up and up. So this is how I calculate the rolling mean, and also when it pushes the GSR data into a list. So yeah, from the starters, because I had to split and parse, make it into float because it was in string, no, in byte format, and I append it into a buffer and then I calculate the rolling mean. And then after everything was done, after the window size exceeded, I concatenated the cache rows into a single data frame and appended the concatenated data frame to the existing data frame. So this is the result that I got. There was like some problem with Empatica, so I had to kind of make a sample data set to show this visualization, but this kind of mimics the real output. So basically what I did was psychological synchronization usually takes EDA 82 minutes. This was one that I searched from literature. So I figured 75 minutes, about 75 minutes is the optimum time for recording this GSR. So I did that. And as you can see, there are some fluctuations. I assume that shows the peak intervals of the GSRs, the emotional peak. Yeah, and the discussion and implications. This allows analysis of team coordination dynamics based on psychological signals, offering promising avenues for practical applications. I've also found in the literature that there are some limitations for these kind of devices, because in order to access this kind of data, you cannot just rely on one type of data that you get from Empatica, but you need different modalities. So that should be considered in the later research. Also, Empatica was kind of an unstable platform, so maybe there could be a different device that supports this pipeline. And also caching requires a lot of memory usage, because the temporary caching, if you don't delete it afterwards, it keeps on building up. So yeah, that was the limitation. That was it. Thank you so much.
Okay. Travis, do you want to go first? Because I know most of this already.
I think you should go first and ask some questions, and then I'll go next. And then after that, we can stop the recording.
Yes. So one thing that I thought maybe you should explain to Travis is the technical issue that we had in the beginning, which is why the project got a bit delayed, or we didn't get as far as we wanted to.
Yeah. So basically, we started this when we first started using this Empatica device, there was already a pipeline in C# and different languages. So we tried using that to see as a guideline, but it all didn't work. Turns out we were having some email conversations with the company and also calls, but they couldn't figure out the what was wrong, because every time we tried to run the example code, it kept on showing error. And also there was a connection showing, but in reality, there was no connection between the Empatica. And we were doing it, and luckily at the end, with the help of the external provider, we figured out that you basically have to reinstall the streaming server every time you run the code. So you run the code, and then you, for the day, you're done. You close the laptop, you have to reinstall the streaming server again to make it work. So that was a kind of a difficulty. Yeah. Also, the Empatica didn't offer the online version of accessing its data, so we had to use the local host version. So I used the Anaconda, Jupyter, and localhost to access the data. Yeah, this took quite some time to figure it out. I would say at least 3-4 weeks was spent on this.
So how would you say then, this experience, sort of the hurdles that you had to go through to get to this point, like what do you learn from that?
Oh, you have to get help from everyone. Beggars can be choosers, I think. Yeah, like I think I and Kiana also helped. We contacted everyone that we could find. Also, Kiana's acquaintance helped us a lot. So yeah, that was the most important thing. Also, I realized that because once you sit down and try to work on a project, and you keep term in between those working dates, so you work on Monday and Friday, you kind of forget everything. So it's important to set the flow or make a deadline for yourself. If you worked on this Monday, then you're going to do the next step on Wednesday and then Friday. So I learned that. Yeah.
And is that something you think that's specific to like a programming based project, or
Yeah,
to all
also
kinds?
to programming based, because let's say, because I think most of the programming software companies use agile approach, so they do lots of scrums, meetings, um, quick, repetitive. So I assume that kind of approach can also be used in school when I'm doing a programming related course, when I'm finishing that kind of project.
What kind of meeting did you all have? Was it weekly or every couple of weeks?
Yeah, weekly. We normally had 2 meetings per week, but as time progressed, we realized that uh, we didn't have that much time left, and also the exams were approaching, so we couldn't spare more time. So uh, we intensively met and then started working. Yeah.
Mhm.
Yeah, but I think our meetings mostly look like we sat together for a little bit, and then they went on with the Empatica to do his own thing.
Okay. What do you think is the viability? So you mentioned here there's some limitations about it being unstable or memory usage.
Mhm.
Do you think those things are things that prevent this from being actually used in, say, a research context, or things that would need to be solved first, or what's your reflection on that?
Um, I think you have to, maybe there should be a differentiated approach to this. So for example, if there's experiments on smaller scale, like let's say for example less than 20 minutes or 30 minutes, I don't think we need to take this approach, because this approach is suitable for more larger, like 7,500 minutes. So in that case, we can maybe allocate a big data frame and then just use appending list and just appending to the data frame. That kind of approach also works, and that's way more simpler. So I would say that's more applicable. But in a bigger scale, uh, I think of course there should be some changes to the feature processing parts and pre-processing, but I think it's usable.
I didn't quite understand your point about the time duration. Was that based on the windowing sizes that you chose, or what was this motivation for it's better for longer times versus shorter times?
So there was just like this literature
Yeah.
that did similar experiment with the team coordination,
Yep.
and they were dividing the experiment into two parts, 30 minutes, 30 minutes, around 30 minutes, 30 minutes. So I assumed we could do the one whole experiment around that range. And also 75 minutes, 90 minutes is about the time that football players play. So I got the idea from there.
Could you go back to your slide with the figure on it? Yeah. But so these are minutes, right, on the bottom?
Yeah.
So even if you had a 25-minute task, you could still see the sort of general decline in the GSR from the rolling mean, I guess.
Yeah,
Or the sort of drop and then increase, but a general decreasing trend.
Yeah, from the rolling mean.
Yeah. What's your take on the variability that you get in the GSR versus the rolling mean?
Variability, as in?
Yeah, so it's the signal looks quite variable. I don't know, Kiana, maybe you also look at it and it looks fine, but
I mean, if I look at the scale, it looks okay. But yeah, I was wondering about the rolling mean, so maybe you ask yours first and then.
what are the units here?
So it's the y-axis is the US. Yeah, and then the x-axis is the so this one is 30 times 4 HC, so 100. Yeah, so it's sorry, it's the data units, data points. Yeah.
At the whichever sampling rate it was. Okay.
4 hertz.
What's that?
4 hertz.
Okay.
Can you maybe briefly explain this rolling mean to me? It's based on what window?
So it's 30 4 hertz times 30, so 120.
So that's what you calculated the mean over. 120
and
values.
then after that's filled up, and then it moves on to the next one.
And what was your reasoning behind the rolling mean?
Actually, it was kind of arbitrary. So it was 4 hertz, and then 30 seconds came to my mind, so 120.
Okay. I mean, I see the value of a rolling mean because it gives you a smoothed signal and it shows sort of the trends over time, because not much you can see from the raw signal, I think. So that could be a reason to have a rolling mean. But yeah, I was just curious about why you implemented it.
Yeah.
I suppose in principle from the code, whether it's a rolling mean or any other rolling metric, it's easy enough to modify, right?
Yeah.
So I think the one thing that I'm curious about as well is that you focused on real-time sort of streaming and accessing the data, but then you talk about, well, it's important to have this very long period. And I feel like those two things are kind of not compatible in a way. Like if you want to really just say what is the GSR right now, or what is it, in 30 seconds, and you want to continuously access that, do you still think this is the way to do that, even if you recommend looking at the signal over a longer period?
I would say in that case, instead of using the filling out method, so after you filled up and then calculate rolling mean and moving on, maybe we can use just appending into the list of data frame, and then we just calculate as it goes by. That's more practical if we are looking at the real time.
So this is related to your functions that you wrote. Could you
Yeah.
go back to that slide that you had?
This one?
No, you had one where you had like two functions that, yeah. I think you passed it.
Oh.
It was the store and blah blah blah, and then the
Yeah, there's no
one.
numbers
Yeah.
on these slides, so otherwise I could say the number unless it's hidden behind the
Sorry.
window. Yeah. So is this what you mean, that the store and clear, this is the one that sort of stores a fixed amount?
Yeah. Yeah, exactly.
So would it be as simple as, I mean, I guess in principle, you mentioned that it fills up, right? And there's some memory demand for this. So that would be sort of a trade-off that if you want something showing up more rapidly, then maybe you need to have a smaller cache, I guess.
Yeah.
And then you need to clear it more, but maybe store it separately, or. Actually, Kiana, I'm interested in that because, one thing that we might do, right, is use the metrics, and I guess there's some degree to which we might want to display them or use them versus storing them. I'm not sure what your thoughts are on that.
I think we should definitely try to have some visualization of the metrics, but I was also concerned about the computational power, because I think the caching of the 30-second length makes sense to me, but rather than having but if you want to be able to display sort of in real time or near real time, we should instead of having one window and then throw it away and then the next window, we should probably have it sliding with the 5-second difference. So first you start with 1 to 30 and then 5 to 35. But that would be more computationally intensive, and I don't know how that would go.
Yeah, because also one of the limitations of caching was the high computational power. So it would not be that practical.
Yeah, so I thought about this as well, and well, we could simply try to keep like a CSV that gets updated, but I think when I was looking, this caching system is also what I found to be was used. So that I would also go by that.
Okay. I guess I wonder if there's also some degree of testing like these parameters, for example, and seeing, you know, what really is too computationally demanding, because I guess with certain equipment, it doesn't really matter, right? If you have enough memory and enough storage, then it doesn't matter, but maybe on some systems it does.
Yeah, that would be an interesting experiment actually to test that. What are the limits?
Yeah. Did you have any other questions for Kiana?
I just wanted a quick mention that in the last slide, I think you say psychological signals, but where it's physiological signals.
Physiological. Yeah. Sorry about that.
No, but I just want you to be aware of it.
Yeah, it looks like your last format here got a bit messed up also. Yeah, so what are next steps here? How's your report coming along? Have you submitted it yet?
No, so deadline is Sunday. I'm still yet to submit my first draft to Kiana, so maybe she could take a look at it this afternoon, and then
Then you might still have some time to address any issues in there before the deadline.
Yeah.
Okay.
Yeah, we discussed that I would get it by 3 so that I would have some time to look at it before
the end of the day.
Yeah.
Okay. Okay, so let's say that all of that goes well. I'm curious, two things. Like, Tay, do you feel like, oh, you've had enough of this, you know, you will just move on with other things, or do you feel like, you know, you might want to do more in this kind of direction?
I haven't thought about it, but yeah, maybe I'll have to think about it because next semester I'm starting another internship also. So yeah, I need some time to think about it.
Yeah. No, that wasn't meant to put you on the spot.
Yeah.
It is something I think you also have to reflect on a bit in your report as well. Like, how do you see how it went, and were you happy with how it ended up, you know, despite the challenges that you faced in the different routes you had to go? What about you, Kiana? Do you, I guess one more question for Tay is your code on a repo somewhere that's made accessible, or what's the plan for that?
Yeah, if required, then I'll put it on GitHub if it's needed.
Yeah,
Kiana, do you have a
definitely
preference?
share it. We have a shared drive where there is some shared documents, but if it's easier, I don't mind if it's on GitHub or on the shared drive, but I need to also have access to it.
Okay, and then Kiana, I'm curious on your side. You could also tell me later, but do you feel like this is a good, like, you can build from this for what you need?
Yes. I mean, the most important part to me was getting the real-time data from the Empatica. And that we do have, and I think that we came up with an approach to develop like with the cache, the store and cache. So yeah, I will be able to use this, and yeah, it's nice.
That's good to hear. And I guess the issue that Say mentioned about having to restart was it the server, the streaming server or something?
Yeah, you have to reinstall it.
Reinstall it, yeah. I wonder if that could also be done in a step with the code as well. That way it sort of reinstalls it each time the code is run, if it's required anyways. But I'm not sure what that would look like, but just an idea that came to mind.
Yeah. Yeah, that could be an idea.
Yeah.
So we had 30 minutes for this meeting, right?
Yeah.
Yeah. Is there anything else either of you want to discuss, or
I'm good.
Yeah, same.
okay. Tay, when you submit your final report, will you also email it to me?
Yeah.
Okay. I was just looking on Canvas, and I'm not sure that there's a ton of different internship courses, so it'll just make it a bit easier for me to read it first, and then I'll find where you are on which one on Canvas to put the evaluation on.
Yeah, for sure. Thank you.
Cool. Thanks for your presentation. And nice effort. I'm glad in particular that you found something that works and is a good basis for what can be used in the project. So nice job.
Yeah, thank you so much for the supervision for both of you.
That goes mostly almost entirely to Kiana, of course. So
Thank you.
and I guess the other help that you got from Empatica,
Yeah, the other quarter is
your
Paris.
colleague. Okay, thanks to Paris as well.
Yes.
Well, good luck finishing up the report, and have a nice weekend.
Okay. Bye.
Thank you.